Hello, this video is going to take us through a hypothesis test for the difference of two proportions. Generally, your null hypothesis is going to be PA equals PB, although you can also see it written as PA minus PB equals 0. So just subtract PB from both sides. So this gets at the difference maybe a little more specifically. Take note, same as before, context A and context B must be defined. The order of the difference must be specified, and subscripts can indicate context. It can get very confusing. So now we're going to do the right-hand column of the next page of notes, because the right-hand column is the hypothesis test. So, first check, same as the first check with confidence intervals. You have two independent populations or groups. So you must first check, do you have independent populations or groups? If you have an experiment, this condition is met as well as the next one. But this is a check, it's always scored. Actually, all of these now are always scored. So, and for me, they were always scored anyway. So then you get into making the table, context A, context B, randomness, independence. Check, is randomness met in context A? Is independence met in context A? Population size, context A greater than or equal to 10 times the sample size of context A. And then context B, does it say random? And then population size in context B is greater than or equal to 10 times the sample size in context B. Or if you have a randomized experiment, it meets all four of these. But you also have to clearly make sure you're stating it met this first condition. We are going to skip the normal approximation check for one moment while we do something, while we set up the hypothesis test. So we use the hypothesis test to test a claim about a difference. P sub A minus P sub B. The hypotheses, which you will typically see either written as P sub A equals P sub B, or the null is P sub A minus P sub B equals 0. And then take note your alternate. Now, depending on how you do it, you're just going to change the equal sign into a greater than, a less than, or a not equals to. So P sub A is greater than P sub B, P sub A is less than P sub B, or P sub A is not equals to P sub B. This is called a two-sided test, and all of these are called two-sample tests because you have to take two samples. So now, we run into a problem here because in order to use the hypothesis test, we're assuming that these two values are equal, but we actually have no idea what the value is. So there's a new quantity that will be calculated. You may see it called P hat sub C, or more commonly now, P hat. That's what your calculator will call it, P hat with no subscript. Here's how it is calculated. It is equal to the number of successes in context A divided plus the number of successes in context B divided by the sample size in context A plus the sample size in context B. So before you do the normal approximation check, which we're going to make use of this to do the normal approximation check, you probably want to make sure on your paper you have shown the calculation of P hat sub A as a fraction. You have shown the calculation of P hat sub B as a fraction, and then you show, very clearly show, the calculation of P hat. It's called the combined proportion. So now I'm going to jump back to the checks, because this is the proportion we're going to use to check up here. So for hypothesis tests, this check is going to look like N sub A, so the sample size in context A, times P hat. It's greater than or equal to 10, and sample size in context A times 1 minus P hat. This P hat is the combined proportion. And then do the same in context B. n sub b times p hat is greater than or equal to 10, and n sub b times 1 minus p hat is greater than or equal to 10. So theoretically, all three of these calculations should be shown as you do the checks, because you will need to have this. So now, typically at this point, you are now going to use step 5. Typically at this point, you're just going to use 2-prop z-test. And then from the output, you'll write that, so 2-prop z-test. And this is permitted as long as you actually write that, so I did check on that. 2-prop z-test. Then you will write the test statistic. The test statistic in 2-prop z-test is listed as a z, and then you will write the p-value, put a colon, and just put it. Keep in mind, don't write p equals. It could get marked wrong. So now, if you desperately wanted to calculate the test statistic, you would do p hat sub a minus p hat sub b minus the difference you claimed from the null, but generally that difference you claimed from the null is 0, so this is often not shown. And then this is divided by p hat, the combined proportion, times 1 minus p hat, all over the sample size in context A, plus combined proportion times 1 minus the combined proportion divided by the sample size in context B. And then the p-value, since we do have a z as a normal CDF, if you wanted to calculate it on your calculator. And keep in mind, for those of you that are still doing this, you can only lose points. You cannot gain points. So if you're showing me the calculation, you can only lose points. There's no way to gain points by doing that. Now this one, it's a common multiple choice fill-in-the-blank question, so I could see maybe doing this. But showing the calculation, normal CDF, if your alternate is greater than, you would go from the test statistic and higher, so the lower bound test statistic and then the upper is something high. If you have less than, you'll go something really low, and then your upper bound is the test statistic. And not equals to, I take the absolute value of the test statistic and go and do the same for greater than. So the test statistic to something really high, I calculate that in normal CDF, and then I multiply it by 2. Then you're going to make a decision about the null. You'll either reject if your p-value is less than the general is 0.05, or you'll fail to reject if your p-value is greater than or equal to 0.05. And then you'll draw a conclusion. You either have significant evidence or you do not have significant evidence. That is the conclusion about, and you'll describe the alternate in context. Some follow-up questions for a hypothesis test. Some follow-ups that I came up with is you could have errors, a question about errors, you could have a question about powers, you could have a link to a confidence interval, or, interpret the p-value. And then there's a note here, I give you the standard error here. This is the standard error written the way I will write it, generally. This is mathematically equivalent to this, and you'll sometimes see that in some books. So if you see it that way, you're not stunned. Okay? Thank you.